Hello, welcome back to 9.4 Transforming Quadratic Functions. Again, we're doing the problems on the textbook, page 617, right before we do the homework problems. So again, if you are working on the homework, watch this video, then pause it and do these problems so that's fresh in your mind. We're going to compare each of these graphs from 5, 6, 7, and 8 to the parent function f of x equals x squared. Now, you can also take out Desmos and compare, that's fine. But we're going to do this without Desmos. So let's look at g of x. Excuse me. So this is 1 times x squared, just like this is also 1 times x squared. So the width of the graph is the same as f of x equals x squared. It's not any wider, it's not any narrower. Also, there's no negative here, okay? So there's no flip or vertical, as we want to be more specific, reflection. So in other words, that's a smiley face, that's a smiley face too. The only difference is this plus 6. So, and actually, to be honest, you could probably get by without saying anything. I'm just doing it because I'm in teacher mode. I do have a plus 6. That means that I move the graph all the way up 6 spaces. So we call this a vertical translation. Translation means slide. Up 6. For number 6, now instead of just x squared, I've got negative 2. There's two things happening here, okay? The 2 tells me that I have a vertical stretch by 2. That means that it is more narrow. So if you have a multiple choice test and it says which one's more narrow, that's what I'm looking for. I'm looking for, without the negative sign, I'm looking for a big number there, like you saw me do in the last problem or last video. The negative tells me that I have a reflection. So I have a vertical reflection. And that means I go from a smiley face to a frowny face. This one's upside down, it looks like this. And the plus 5 tells me that I have a vertical translation. Positive 5 means up 5. So the whole graph got pushed upwards 5. So there's 3 things that are happening, okay? And they do kind of go in order. Multiplying comes before adding, so they do kind of go in order. These two happen at the same time though. It got flipped and it got stretched, so it was made skinnier. Then when I added 5, it pushed the whole thing up 5. For problem number 7, I'm not adding or subtracting anything, so there's not going to be a vertical translation. All I have is this 1/3. So this is wider than f of x equals x squared. However, let's be more specific. This is a vertical compression, because I squeezed it, by 1/3. There's no reflection, so it's still a smiley face. And there is no translation, vertical or otherwise. Finally, for problem number 8, just like this one, I have 3 things. This one only had 1 thing, that one only had 1 thing. This one has 3, the 1/4, the negative, and the subtracting 2. The 1/4 means I have a vertical compression by 1/4. That means it is wider than the parent function. The negative tells me that I have a vertical reflection. So this one is a frowny face. And the last part, the subtracting 2, tells me that I have a vertical translation. Oops, I bumped my paper, sorry. Vertical translation by adding negative 2 means that I'm going down 2. Okay, so ask questions in the discussion if this didn't make sense. I do want to include one more thing before I sign off with this video. Notice that everything on here is vertical. So we talk about vertical stretches, vertical compressions. So vertical compression, that's a vertical stretch. All right, this one wasn't either. We talked about vertical reflection, flipping it up and down. And we talked about vertical translation, sliding it up and down. Vertical means going up and down, okay? The big question is, what about horizontal? Do quadratic functions or functions in general, do those do anything horizontally? The answer is yes. However, we don't talk about it in this section because there's some more math that we need to get to. So we will be coming back to this. As a matter of fact, we won't even do it in this chapter. You won't see it till Algebra 2. But the answer is yes. See you in the next video.